Okay, so we took a look at how to use the bond pricing formula in Excel, and also we managed to find the yield to maturity when we knew the price, the face value, the coupon rate, and the frequency of payments. And during these examples, we saw how coupon payments are calculated, and coupon payments are calculated as the ratio between the product between the coupon rate and the maturity value divided by the frequency of payments. Okay, so this is the way in which we calculated the coupon payments in the examples. And now let's take a look at what we have done in the Excel example, right? When we assumed that the yield to maturity was equal to 10%. All we have done was to use the bond pricing formula, okay, that we have introduced before. And remember that the bond pricing formula was equal to the sum of the discounted coupons for s going to 1 to n times t plus the principal amount discounted back to present. And we knew that the bond price was equal to $655.90. So we also knew that the coupon rate was equal to 7%, the face value was equal to $1,000, the frequency was equal to 2, the time to maturity was equal to 15 years. So all we had to do was to find out the yield to maturity. And we proceeded with trial and error. So we substituted all these data into the bond pricing formula. So this is the first component, which is the component of the discounted cash flows. This of the discounted coupons. This is the second component, which is the principal discounted back to present. So in the end, it turns out that if we substitute these numbers into the formula, we get that the present value is equal to $769, and it is bigger than the price. So the yield to maturity cannot be equal to 10%. Then remember that what we did was to find out the present value and compare it with the market price of the bond when the yield to maturity was equal to 12%, and that's what we have done. So again, here we have the bond pricing formula, and here all we did was to assume that the yield to maturity was equal to 12% and not 10%. So we did that, and we plugged all the numbers in the formula, and we found out that the price is indeed equal to the present value of the bond, which means that the yield to maturity is indeed equal to 12%. Let's take a look again to the bond pricing formula, because what we have done so far was to find out what the yield to maturity was if we knew the price. Okay, so let's recall the bond pricing formula, which we have derived in the previous modules, and which we have also used a number of times in the Excel examples. So remember that the price of the bond is equal to the sum of the discounted discounted cash flows that the bond offers throughout all its life. Okay, so more generally, if the coupon and the maturity value of the bond are known, if you know the price, then we can derive the yield to maturity, as we did before. Or equivalently, if we know the yield to maturity, we can derive the price of the bond. So what does that mean? It means that the yield to maturity is an alternative way to express the bond price.